Antifreeze-producing frogs may be in trouble, and a queer scientist is finding out why. Hi, I'm Keegan. I have a degree in wildlife biology. Let's talk about it. A study recently published in Journal of Animal Ecology called Freeze-Tolerant Frogs Accumulate Cryoprotectants Using Photoperiod, a Potential Ecological Trap by Neptune, Koester, and Bernard has raised alarm bells. Eastern gray tree frogs, Hyla versicolor, are a species of amphibian that produce natural antifreeze in order to prevent freezing in the winter. This antifreeze is in the form of glycogen, which the frogs store in their liver. Troy Neptune, who uses he/they pronouns, love the shirt by the way, led a study to find out what environmental factors trigger the production of glycogen. They raised eastern gray tree frogs from tadpoles in custom outdoor enclosures that allowed for the manipulation of photoperiod. Basically, a cover was placed over the enclosures to simulate sunset and nighttime. Some frogs experienced short days to mimic winter, some frogs experienced moderate days to mimic fall, and other frogs experienced long days, reflecting the summer. Importantly, all of the frogs experienced the same summertime temperatures. Once the experimental period ended, Neptune looked at the glycogen levels in the frogs' livers. They found that it was not temperature, but photoperiod that triggered the production of antifreeze. So, what does this mean? Well, the problem is that as the Earth's climate warms at a rapid rate, winter arrives later and is more mild in the northern hemisphere. But the bodies of these frogs can't catch up, resulting in wasted energy put towards antifreeze production, rather than in growth or reproduction. In addition, ectothermic animals rely on environmental temperature to control their metabolism. Warmer temperatures means a faster metabolism that requires more food. If frogs need to eat more food later into the winter, there may be fewer meals available, and we could see starvation events. Finally, reptile and amphibian keepers may know that brumation is often tied to reproduction in many species. It is possible that we may see a drop in fertility in these frogs as a result of later, milder winters. But it's not all doom and gloom. As a queer scientist myself, I find it exciting that an LGBTQ+ scientist is leading an experiment such as this. In addition, the information that Neptune and their research team have uncovered can be used to inform the management of many amphibian species, not just the non-threatened eastern gray tree frog. So, how do you think this information can be used to study amphibians, or in wildlife management, or even in the frog-keeping community? As always, I welcome your thoughts in the comments, and have a good one.